All right, today we're going to talk about compound inequalities. We just finished graphing and solving inequalities in one variable that we call them simple inequalities, where it's just like a single inequality one at a time. A compound inequality is when you have two of these simple inequalities, and they're going to be joined together using the words and or. Okay, these little connector words. If you think about compound sentences in your language arts class, that's where you have two standalone sentences that are combined with the words either and or in between. Okay, so compound is when you join two things together. So in this case, we're joining two inequalities together to become one compound inequality. So our focus today, our essential question is, how do I solve compound inequalities and also graph the solutions? It's going to look just a little bit different than what we did in our first lesson. So we're going to solve each simple inequality to solve the compound inequality. So let's take a look at our first example here. We have 2x is greater than 10, or x minus 3 is less than or equal to negative 4. So don't you notice the compound word or is connecting the two simple inequalities together into this one compound inequality. Now, if we're going to solve this, we want to solve each simple inequality by itself. So it looks like in the first inequality, 2x is greater than 10, I would need to divide by 2 to get x by itself. I would get x is greater than 5. Keep in mind, I don't flip the inequality symbol here because I wasn't dividing both sides by a negative number. I divided both sides by a positive 2 instead. So that's only part of our answer. We still have that connecting word that we're going to use in our solution, in our answer, but now we need to solve the second inequality. X minus 3 is less than or equal to negative 4. To get x by itself, I would add 3 on both sides. That's going to undo the minus 3. And that's going to leave me with x is less than or equal to negative 1. So that's my solution. It's the whole thing put together makes up the solution. That's not two solutions, that's one solution, a compound inequality. So in our little talking bubble here, it does also remind us that when graphing an or statement, where you have the word or in between the two inequalities, we include any solution to either inequality. So basically, we graph both of these on the number line. So my first one said that x is greater than 5. So I'm going to find the number 5 on my number line. I am going to make an open circle because remember, it doesn't say greater than or equal to 5. So 5 actually isn't a solution here. So I don't want to fill in the circle. But I do want to show where are all the numbers, where are all the x values that are greater than 5. And that's going to be to the right of 5. So open circle, and I draw my arrow to the right. Now, the other part of our solutions are all the x values that are less than or equal to negative 1. So I find negative 1 as my boundary. My inequality symbol is less than or equal to, so that means negative 1 is in fact the solution this time. So I want to go ahead and fill that in completely and have it right on my boundary value of negative 1. And since it says x is less than or equal to negative 1, I want to draw my arrow to the left for all those numbers that are less than negative 1. The circle, the closed circle that's filled in, covers the or equal to part. So any number that's either greater than 5 or less than or equal to negative 1 in this case would be a solution to this compound inequality, because the word or implies that it can be a number that's a solution to the first part of the inequality or the second part, either one. Let's take a look at a different kind of compound inequality. This time we're looking at a compound inequality that is using the word and to join my two inequalities together. X plus 5 is greater than or equal to 5, and negative 3x is greater than negative 9. Let's start by solving each inequality, then we'll talk about what that word and really means. So in the first inequality, I have x plus 5. So to get x by itself, I'm going to go ahead and take away 5 from each side. That's going to leave me with x is greater than or equal to 0. I want to make sure that I include the word and in my solution. And now I solve the second inequality in my compound inequality. Negative 3x is greater than negative 9. I have to divide to solve this inequality. But when I divide, I notice that I'm dividing by negative 3 on each side. There was a rule that we talked about in the previous lesson that anytime we divide both sides of an inequality by a negative number, we must reverse the inequality symbol. You notice how we changed? It was greater than, now it's less than. And that's because when you do that, when you multiply or divide both sides by a negative, it changes which side actually is larger. So in this case, now the right-hand side is larger. And negative 9 divided by negative 3 is a value of 3. So our solution for our compound inequality is x is greater than or equal to 0, and x is less than 3. So in this case, what we're trying to do is we're trying to find the values for x that are greater than or equal to 0, and they're also less than 3. So let's take a look at each one of these inequalities separately on the number line. If I were to graph the first inequality, x is greater than or equal to 0, what kind of circle would I use? Would it be open or would it be closed? Well, because it can equal 0 based on that inequality symbol, I would use a closed circle. And because it's a greater than 0, I would draw my arrow to the right. For x is less than 3, I would use an open circle because it's one of those strict inequalities. And I would want to find all the numbers less than 3, which would be to the left, working towards those negatives. Now you'll notice here that we have an overlapping area in the middle, in between those two boundaries. And actually, if you think about it, is a number like negative 5 a solution to this compound inequality? Well, is negative 5 greater than or equal to 0? No. Is negative 5 less than 3? Yeah. So is negative 5 greater than or equal to 0 and less than 3? No, it's not. Because the word and implies that the number must be a solution to both of the inequalities at the same time. So the only numbers that are going to be solutions are going to be where our two arrows overlap, the two shaded areas that contain the solutions of each individual inequality overlap. So we're going to go ahead and redo this. And I am going to basically just, now that I know where those two overlap, I'm going to draw my boundaries. That I have a closed circle at 0. I had an open circle at 3. And I know that the two overlapped in between. So those are the only numbers that would be values for x that would solve this compound inequality. Basically, it's the numbers between 0 and 3, but we also include 0 as a solution because that circle was filled in. 3 is not included in the solutions because it was not filled in. Let's look at one last problem. This is a special type of compound inequality, and it's really only special because of how it's written. This is actually the same thing as one of our and statements. It's just a unique way of writing it. To solve a compound inequality like this, maybe you notice that there's two inequality symbols here. There's one on the left-hand side, one on the right-hand side. So when we solve this, what we're going to do is draw double train tracks, and we're going to put our focus in the middle, where the variable is. Whatever we do to the middle of this inequality, this compound inequality, to get x by itself, we do to the left, the middle, and the right side of our compound inequality. So if I want to get x by itself here, I have to undo the plus 3. So we're just going to subtract 3 from the middle, from the left, and from the right-hand side. When we do that, we get x by itself in the middle. And all I did was subtract, so my inequality symbols will stay the same. I just bring those straight down, right in line. And then I have to simplify the left and the right-hand side. On the left-hand side, -4 minus 3 is -7. On the right-hand side, 8 take away 3 is 5. So I get -7 is less than x, which is less than or equal to 5. Now let's graph. Graphing these actually ends up being kind of fun. I like graphing these. I'll show you the quick, easy way of doing it, and then I'll show you why that works. So what we want to do is we want to focus on our target values and the type of circle that we're going to draw. So on the left-hand side, we had that -7 is less than x. So that means we're going to use an open circle because it's not the equal to inequality, it's just less than. So we're going to find -7. We're going to put an open circle at -7. Okay, don't draw your arrow yet. We're just going to draw the boundary circle. Now on the other side, we have that x is less than or equal to 5. For that, we draw a closed circle at 5. 5, draw a circle, fill it in. And just like we saw in the last one with that and statement, it's going to overlap in the middle. If we were to take these inequalities and write them using the word and, what we would do is we would take this first inequality, -7 is less than x, and actually reverse it, write it the other way with the variable first, because that's normally how we would graph on the number line. We would say that x is greater than -7, and then we take the second part of it. X is less than or equal to 5. And that's what we have graphed here. We had the open circle at -7, open because it was not equal to. And then since it was a greater than symbol, we think about it as being graphed off to the right-hand side, all the numbers to the right of that. And then for our second inequality, we have a closed circle at 5 because we do have the equal to symbol. And x is less than 5. So we want the numbers less than that or smaller than that would be to the left. So where would the numbers be that are greater than -7 and less than or equal to 5? In the middle. Now keep in mind, because 5 is filled in, 5 is actually a solution here. If you think of it, 5 is greater than -7, that's true. 5 is less than or equal to 5, that's also true. If you were to check -7, we can see it's an open circle, which means it's not a solution. And the reason why is the first inequality. Is -7 greater than -7? No, it's not. It's not a solution to both inequalities, so it's not a solution to the compound inequality because of the word and.